Okay, welcome everyone. Today we will have a speech about, as you see on the screen, batteries and battery management system in automotive applications, right? So that given by one of our MSc students, Caner Yasav. So Caner working on this MSc thesis, and he will work on the batteries and as given on the board. So that I will leave the speech to the Caner. Okay, Caner, you may start. Okay, thank you very much.
Thank you. Dear participants, our lecturers and friends, first of all, I would like to welcome our seminar that will be presented by me. And I am Caner Yasav, and currently, I am a master's degree student at the Yasav University with the Department of Electrical and Electronics Engineering. So also I am working as an electrical engineer in the company that we located in the Manisa. So it is responsible for the in-house development for the heating and cooling systems. And also they try to develop some battery management systems and the charging stations also. So before my presentation, I would like to thank you with my, first of all, Mustafa Günüzap and Mustafa Seçmen to providing me to show my seminar presentation here. So as we know, the batteries and the battery management systems will be popular in the near future because we all need to have some electrical vehicles maybe in a near future. So in Turkey, we actually try to be prepared for that. So our main topic is about the batteries and battery management systems with the automotive applications. So at this stage, we have an outline, and the outline includes the electromobility at first. Then we will talk about the introduction of the battery and some examples and some terms of the battery management systems. And with figures, I try to explain some basics of the battery management systems. Then we can talk together for the new technologies about that. So here, as we know that the electromobility is a very popular topic we need to make some transitions from the internal combustion engines to electrical vehicles. Also, we have some topics to some needs and requests for the electromobility. So you can see that these are, we have the environment problems and the economy and the society, technology, politics, and infrastructure problems here. So first we need to use electrical vehicles because of the climate change here. So also we need to reduction to global carbon dioxide emissions and some noise emissions that we will know that the electrical motors can have less noise, and the internal combustion engines will have a greater noise here. And also we need to have some awareness of the consumption of the raw materials here for the environmental problems. And then the economical problems we have, such as the limited oil reserves, rising prices for the fossil fuels, and the desiring for impediments for the oil exporting countries actually. Then also we are society, we have some society problems that our popular mega cities is growing with the mobility, and we need to increase the acceptance for the electromobility and the demand for the vehicles with lower consumption and emissions. And also we will know that the increasing the urbanization is a very close to us actually. Also the technology is developed in the past, in the so close past. So we will have some technical advantages of the electrical motor. So they have saved about the 98% the energy saving with the comparing with the internal combustion engine. So it will help to increase the efficiency, and also we will have some high voltage safety with the new technology developments here. Also, without politics we cannot go further with the big chains actually. So they need to determine some international specifications for the emission limits with the new world. And also they should make sure about the introduction of the low emissions and the emissions free zones here for our cities. And they need to develop plans and subsidies actually. So finally, we need to some manufacturing on the and infrastructure to compressive infrastructure to supply energy for electrical vehicles, because we need to use the cars and we need to charge them at home, at work, and or the roads. So we need to go further with the range of the miles and the kilometers with our electrical vehicles in the near future, actually. So this is all that I want to talk about electromobility actually. So when we come from the batteries, actually we will have some basic terms for the electrical battery, that they consist of two more electrical cells connected together in a one pack, at least two electrical cells, and they convert the chemical energy to electrical energy to use the drive to motors with the electrical energy. And they consist on positive and negatives electrodes in an electrode, and the chemical reaction with these electrodes which generates the DC electricity. And they can be reversed by reversing the current, and the battery return and the charge states. And we can say in the next slides with some chemical reactions for them. So actually, with the designers and the engineers, some black boxes we can determine for the battery. Then we call it the black box, and they will have some range and some performance criteria actually. So it includes the specific energy, the density, the power, some voltages that we connect with the vehicle and the battery, and the ampere efficiency for the commercial vehicles such as the bus, minibus, and the other highway vehicles. So we need to determine the energy efficiency, the availability to use electrical batteries, and the cost, temperatures, some tests, and some certificates about the batteries. Of course, we need to know about the number of life cycles and the recharge rates. So here I can separate some terms about the batteries as the general, cells, chemistry, how can we control the battery, and what types of the vehicle that will be used with the electrical batteries, what is the battery healthcare, and we can see that a standard type of battery that will be used in the commercial vehicles. So in general, we will have some terms about the battery connection and the behavior of the battery with the communication with the buses and the commercial vehicles also. So first of all, we will have the series communication with the battery, as we know as the series circuit in the sum of the voltages supplied by each individual battery, as we see in the screen in the below. So if we sum the batteries together with the 6 volts of battery, we will get the 12 volt battery, but with the same range of the limit, same life range of the limit with the 100 ampere hours. But when we come to the parallel connection of the batteries, so it is the sum of current supplied by each individual battery. So we cannot change and increase the battery voltages, but we can increase also the range and the lifespan of the battery, as we can see on the figure. So of course, battery, because of the natural behavior, so it is using the energy stored in the battery. So it's while it's use the battery energy, of course, it will discharge and the self discharge with the phenomenon in the batteries. So actually, which internal chemicals reactions the reduce the stored charge of the battery without any connection between the electrodes. So Actually, because of the natural behavior, there will be some thermal runaway problems occurs in situations where an increase in the temperature and it changes batteries, active materials in a way that and they causes a further increase in temperature by self-heating, often leading to destructive results. As in the picture on the top of the screen, we can say that one cells cause the thermal runaway and it will be propagation for the all battery system. So the most popular, the communication protocol for the automotive industry, as we know, we can use and we need to use CAN link protocols. So CAN has some specifications that it has a high speed and it has two cables to communication together with the other components. And also we have a link communication. So for batteries, actually, we can say that we have a C rate and which battery is being charged or discharged. We can calculate it. And it's defined the current divided by the theoretical current drawn, under which battery will deliver its nominal rated capacity in 1 hour. So we can say that for the charging and discharging, and the 1 Celsius means that the one will charge and discharge takes in 1 hour, 2.5 hours. It's the 2 hours to charge and discharge the battery. And of course, we will see the other examples in the next slides. We need to charge and discharge the battery also. So we have cells in the battery packs. Also, we will have some terms about the cells that one of them is about the depth of discharge is an alternate method to indicate the battery's state of charge. And the DOD, it is the opposite of the state of charge actually. Also, the batteries has an aging specifications that, for example, one lithium ion cell age both with time and the usage, and the energy is reducing with the storage capability and the increasing resistance to its access. So we have a density, which is the energy stored in a material compared to its volume or the weight, of course. So the overpressure safety device for the cells is like a valve in the cell housing, which opens a specific pressure to avoid the cell from blowing up or some occurred problems for the health. So of course, we like every components and the chemical components actually, they will have some the end of life. So it's also can be calculated with the maximum energy storage loads, and it will be sharing by the battery manufacturers. So we have also beginning of life. So it means that the capacity is full at the 100% with the battery usage before when we start to use the battery actually. So there are some type of cell types for the battery technology that we'll use for the automotive actually. One of them is named the pouch cell, as you can see in the screen. And it is very simple and flexible. Also, it will have some helps to effective and the light solution for the battery design. So, of course, they have some negative types and the sites for the exposure and humidity and the high temperature. So it will have some shortened lifespan and a swelling must be considered for the high cycles. Then another type is named with the prismatic cell, as you can see on the screen. So it have gained some popularity because their large capacity in a currently popular technology. So it have some the prismatic shape, which makes them easy to connect. So another type of the cell is the cylindrical. So this is the most common type, the cylindrical cells that we can use today. It can be manufactured easily because without the automotive technology, we will use actually the cylindrical cells in our world. So the electrodes in a cylindrical cell are bound tightly and encased in material casing. So we can say that it has also the good mechanical stability. Of course, the battery and the cells has a cycle, like the discharging from 80% to 15 state of charge together with the charge from the 15 to 80. So we can say that the partial charge and the discharge will be calculated to the complete cycle. So about the battery chemistry, we will have a 3 type of chemistry inside on the 4 type chemistry inside the battery cells, like the lithium ferrophosphate, nickel manganese cobalt, lithium nickel cobalt, and the lithium ion type of battery here. So in this state, the NCA lithium nickel cobalt has a good lifespan. And also there are some separators that provides electrical insulation between the cathode and the anode side of cells while allowing the lithium ions to pass. So we will have the LFP lithium ferroiron phosphate cell, and also it has some negative sides, the low electrical conductivity actually. So as we talked before, as we know, as the anode is a positive and the cathode is the negative electron. Also, we have the lithium nickel manganese cobalt oxide type of cells, and it is good rechargeable battery, and commonly using the commercial vehicles actually with the rechargeable and the energy capacities. And then the most popular one, lithium, is in the chemical element with the CD line, and the ion is an atom that has a positive electrical charge, and it is getting very popular for the battery technology. So how can we control the battery actually? So there are some type of battery controls, and it's gathered together in a one system to control the battery management in an automotive or the vehicle. So one of them is the battery management control. It is like an ECU, so the electrical control unit is mounted to battery packs, and it helps the monitoring, the measuring, the currents and the temperature values to control the battery pack. Also, we will have the cell monitoring ports. For the each cells, we can say that at least the 16 pack in the cell will be together, get the battery pack in it, and it monitors the voltage, the ampere, and the current, and some temperature values for each 12 cells in the battery pack here. So the main component of the gathering system is the battery management system. Also, it collects the 16, at least the CMBs together, and it is for using the communication with the vehicle to monitoring, measuring, and control the battery technology. Also, we will have some PCBs like every electrical engineer need to be used. So it abbreviations means that the printed circuit board and used for also the battery technology. And also we have the vehicle interface controller. It is kind of a box, the interface box, and inside of it, and it helps to communicate with some protocols to also control the battery management systems. So as we see in the screen, we talked before about the CMB, BMS, and BMC in the battery packs. So we will start with the cells that you can see with the yellow circles, and the one module contains at least 12 cells and makes a CMB in here. So totally we will have the 16 modules to get the battery pack together. So they're all connected to BMC and the BMS system. So the battery management and the battery pack is shown in the figure that we can see here. Also, we have some type of vehicles, electrical technology here. So one of them is about actually the not ready technology with the fuel cell vehicle. It's a type of electrical vehicle which uses the fuel cell instead of battery. So it can be some possible combination with the battery or the supercapacitor to power its boards and the electrical motor. And as I said before, it is not ready to use technology, but it will develop in a near future. So we will have a hybrid electrical vehicle combines with the internal combustion engine with the electrical motor. So we have a propulsion system with the electrical motor. So energy is generated by the recovering system or the combustion engine. So the vehicle can choose any type of energy to drive to go further. Also, we have a plug-in hybrid electrical vehicle. Also, you can charge the battery here. And in hybrid vehicles, we cannot charge the battery, but plug-in, we can plug the system to other battery chargers to charge the battery. And you can use also internal combustion engine together. So another one is that the electrical vehicle is a type of vehicle that use one or more electrical motors. Maybe it will be combined with the front and the rear motors together. So it may be powered through a collector system by the electricity form of vehicle sources, or maybe the self-contained with battery. And the simplest one, the battery electrical vehicle with the pure use chemical energy stored in the battery packs, and it will drive the all power from battery packs to go further with the customers in vehicles. So here, as we talked before, we can show a small figure that you can actually combine and see that the differences of the type of electrical motors here. So we will have here the full hybrid and the plug-in hybrid electrical drive. Also, we have additionally can say that the some range extended electrical drive here, and also the fuel cell drive. It has some electrical motors and the batteries, and you can see some differences here. And the most efficient one for the potential carbon dioxide reduction, we can say the full hybrid is now at the most fit one for that technology. So also we need to care about the battery health because of the customer specifications and satisfactions. So here we need to balance the batteries because of the state of charge and state of health for the all cell battery packs. So it balancing improves the available capacity of the battery pack, and we will see in the next slides for the how can we balance the batteries for each cells in the system. So if we need to use the high voltages, we should actually use a pre-charge resistor. So it is used for the not closing the contactor, which generate a large amount of inrush current when the vehicle is actually used for the ignition at first. So for saving the health of the battery, we need to use the pre-charge resistor. Also, the state of charge is the term for the equivalent of the fuel gauge for the battery pack. So we can say that if the state of charge is the 70%, means the battery still has 70 of the capacity of the energy. Also, there's another safety technology about the battery is an interlock. So interlock is a safety system that connect all the high voltages component together. So as we can see on the screen, so there is a plug with the use the high voltage terminals here. So the inside of the connector, they will have also the low voltage terminals to see that all plugs is connected, all plugs are connected or not connected. If some of high voltage components is not connected, so it will determine there's a lack of energy here, and it disconnect all high voltage components and the battery packs actually. So with the total health of the battery, we can say that the state of health is the battery condition compared to battery specifications. Also, there is some other safety component is about insulation monitoring. So it is some underground system between active conductors and the earth. So you need to connect the earth for the battery management system to more safety, and it is some it has some advantages that allows the continuous operation of the important consumers. So we can see that the standard type of battery pack here. So we have cells gathered in the battery packs of the system, and you can see the connecting the batteries as in series and the parallels. Also, we have the vehicle interface box to connect the other components for the high voltage components in the vehicle. Also, we have safety, the ground connection here, and some plugs for the high voltage and the low voltage connections. Also, we will have some switch box to uh, get balance for the battery cells and the true and the balanced battery system. So also in the battery pack, we can say that some systems for the cell measuring with the temperature and the current. Also, we will have some housing with the mechanical design and the busware to separate and divide some energy to cells with the safety and the three-way. So when it comes about the battery management system, we can say that it keeps the high voltage battery in an optimum condition for as long as possible. All we need and all we know that we will have the further ranges and the big ranges to go from somewhere to somewhere. So in Turkey, we have large highways to go from somewhere. So the battery management system is used for the continuously monitoring the high voltage battery, and it also will generate an error code if some problems occur in the battery. So it will safer than the other controls, and all data is sent to other control units to vehicle with the diagnosis and a tester over a CAN link or the link control. So here is we can say in the figure we have some sensors and the measurement devices here to control the battery management. So temperature sensors measure the temperature of the batteries, so we can cap at the correct temperature. We will have some limits for the safer using at the batteries. Also, we will have some Hall effect sensor measures the current in here. So we can calculate the state of charge easily. And then actually we will have voltage meters determine also the state of charge and provide the data to keep the cells charge balance. And we will have some communicating and a control protocol for the voltage measuring and the Hall effect sensor measuring. So as we talked before, we can say about the state of charge in detail. So it is actually mean that how much energy in a high voltage battery holds. So the state of charge can be determined in various ways. One of them can be used with the current measurement. So both the battery's input and output currents are monitored continuously. So the amount of used or the storage energy can be exactly determined. So actually we can calculate the ampere hour voltage graph. So we can say easily with the measurement values with the voltages. So the amount of energy in the high voltage battery can be estimated with some calculations here. So when we talk about the battery state of charge, we can assume that here the total capacity in it 20. So after some uses of the battery, it will reduce the state of charge is at the 50%. So we can say that with the total capacity decreases at the 50%, then we can say that 10 kilowatts hour energy is in the battery pack at the moment. So then we can say that we will have a charge specifications and a discharge specifications for the battery. As we can see in the graph, if the car drives up with a slippery slope, so the current used by the motor increases. So the motor operates in the electrical motor, and it uses the battery and the capacity of the battery. But instead of this, when the car drives down with a steeper slope, so the current provided by the motor increases, that it can mean the motor operates as a generator and the charged battery actually. So here we can say that all cells have the different combination of the battery capacity. It can be changed for the temperature problems or the using of the cells or the design of the cells. So here we have an example. The war cell actually here defines the quality of the total pack. So the full cells are drained until the cells have the same state of charge. So it will be drained together to get the points from the state of charge limit here. So we can say that this is half capacity is effectively lost actually. And then, so when we assume when the battery is charged, the fuel cell in the high voltage battery will its maximum first, but the other cells is no longer charged. So because it is not balanced here, so we can reduce the efficiency of the batteries because they are all not charged here because the one of them is already fullest in that capacity. And the other one with the all when we assume the all batteries is drained or the empty, so if the high voltage battery is drained, the cell that is least charged will reach its maximum first. The other cells are no longer drained. So we will have some capacity, but we cannot use for the drive the car at least because they all need to balance together with the battery management system. As I said before, the balance is very significant for the battery management. So if the all cells have the exact same charge, then we can say high voltage battery is in balance. So the state of charge can be determined by measuring each module's voltage. So we can say some temperature controls and the cell controls here with the components of electricity. If the modules are not balanced, as we said before, the voltages may very well differ, move more and more over time. So it causes the alteration in the state of charge, eventually rendering it defective. So is a very simple example actually here. So it can be done with the different ways to balance the battery cells. So the passive balancing is the most widely used way. It's so simple with using some switches, as we can see here. And the energy is lost with the passive balancing because the resistor transforms the electrical energy into heat. So we need to discharge and drain the battery with using some resistors, and we need to balance it with the heat transformation to get from the battery here. But also the resistors can be used widely in our technology in there. So the energy is being drawn from specific cells through the resistor to balance the pack. So every module has a voltage gap to show the state of charge. If one cell is charged more than the rest, it can be discharged by switching on the transistor. So you can see on the screen that there is some the switches and the resistors here. For example, in the cell 4, it has a state of charge in 70, and the cell 3 is the 75. So we can say that we can reduce to and use some resistors to drain cell 3 to 70%. And actually with all together, we can all reduce to actually 67 point to balance the battery here. Sorry. And the pack can be also balanced with charging, and with charging technology by routing the charging current partly through the resistor and the transistors. One or more cells can be charged slower, or all cells are fully charged at the same point in time. So we can say that we will use the most having capacity cell here. For example, in the cell 1, we have an 81% here. So we need to open that switch to close the charging battery, and we need to all other cells charge together to get the 81% for the balancing the battery pack here. So instead of the state of charge, we will have a state of health term actually, and it means a health condition of the batteries. So we have some examples about that. For example, a new battery can storage the 50 kilowatt hours of energy, and over time, a used battery still produce the 40. So the HFL is decreases to 18% actually. So another type of example is about the maximum range of the 270 kilometers. And over time, under the same driving conditions, it can be driven for the 250 kilometers. So we can say that it decreases to 93%. Actually, as we said before, the temperature is very important for the battery health. For example, we can say that for the lithium-ion battery, the operating temperature is between the 14 Celsius degree and the 15 Celsius degree. It is the most effective temperature limits for the lithium-ion battery. So to increase its services and life performance, the battery cells are kept need to be between this 25 and the 14 Celsius degree here. And for example, while the driver and the pedal is pressed while driving a car, the high voltage battery's temperature will be increased because the battery always uses to drive the car with the going fast. So it has to be cooled down with the figure of this. So as you can see here, we will have some safety components here with the interlocks and the cell temperature. If the temperature is very high, some components in the switching off, and the battery thermal management system will be active in here. So we need to decrease the temperature of the battery packs here. As we said before, again, so we can say we need to determine, and we can easily determine the state of charge with the ampere hour voltage graph. So the temperature has quite an influence on the cell voltages. Here, the battery management system uses the data to determine the state of charge. So if the temperature increases again, the cell voltage increases mean. So if all cells have the same cell voltages, we can say that the state of charge is same. But the high voltage, if there becomes more and more imbalances, battery loses capacity with the no comeback and the returning the capacity again. So thank you for considering me and providing me and listening me and for that presentation. And we will have some references. And also, I would like to thank you for your attention.